Yeah, kia ora koutou. My name is Chris Cornelisen, and firstly, we'd like to thank the Fiordland Marine Guardians as well as Department of Conservation for holding this event. Give me a great excuse to come back to my roots down here in the south near Fiordland, where I first came. When I came to New Zealand, Fiordland is what brought me here to your shores from America. I'm going to say it, Rebecca, it was 21 years ago that I came into the same research group as Rebecca at University of Otago, so it's great to see a lot of Otago folks here and the research really expanding. And so basically what I'm going to do today is give you an overview of the Meridian energy monitoring program in Doubtful Sound. So when I came here, I only came on a 2-year contract, but I was fortunate to get a job at the Cawthron Institute. So for the last 18 years or so, I've been leading and or engaged in the monitoring program. So what I'm going to show you is an overview of 18 years of data, and in some cases even more than that. And the real point I want to make here is that, you know, I'm presenting on a monitoring program, but if we didn't have this sort of time series data, we'd be pretty much in the dark, to be honest, with the exception of what we've heard today. And those long time series are critical for making those decisions down the line. I also want to just do a shout out to Meridian. I'm not doing that just because Chris Thompson's in the room and she's my main client, but the fact that they actually set, you know, they're a real role model for other companies throughout New Zealand in terms of how you make your data accessible. Okay, so there's a lot of students, a lot of science that's come out of the data that's been used, and they share it quite readily with the science community. So I'll just put that out there. So that's why I have data sharing in my title, and I'll give you a couple examples of how we've expanded our knowledge beyond just consent monitoring to inform us about our special place of Fiordland. So really the purpose of the monitoring is to monitor for the effects of the tail race. But we've shifted into a long-term monitoring program, so it is still that, but with all these heat waves and other things happening, you're trying to monitor for the effects of one activity when actually there's multiple things going on. So that long time series becomes more and more important, as does all the other research that you're hearing about in this room. So basically, as you're probably aware, the tail race has been running, the power station for that matter, for over 50 years. The monitoring began out of University of Otago in '97. I came onto the scene in 2005 when we did a refresh to the program. I'll show you some of the differences that were put in place in 2005, and that's in collaboration with NIWA, as well as University of Otago. We have 2 elements to the monitoring program, the physical monitoring and biological monitoring. And so what you see here is a map of all the different sites that we work at, the green ones being biological sites at one point or another. The red triangles where we've collected physical data, temperature, and or salinity. The yellow squares are MET stations, or where we collect data on weather. Same thing in Milford. We treat Milford as sort of a reference fjord, if you will, a fjord without a tail race. And we have biological and physical systems there as well. This is my list of co-authors for my presentation. Quite a long list there, obviously. Those are all people that in one way or another have been engaged in the Meridian monitoring program over the years, and I undoubtedly have left some people off that list, but just did my best to try and get everyone on one slide there. So just what I'm going to do first is give you a background on the tail race discharge itself, sort of how it operates and that sort of thing, the data that we get as part of the monitoring from Meridian. This shows last year, 2022 into early 2023, and what the tail race discharge is doing over time. So it doesn't go out just steadily, constantly at any particular discharge rate. This was a particularly dry year, so it was actually one of the lowest years for discharge. So it ran quite low at times, as low as, say, even under 100 cubic meters per second. And that's the current consented limit of 550. So there will be times of the year that it goes over the originally consented limit, which was 485 cumex before the MTAD came online in 2012. So that gives you an example of what might happen over a year. These are data since 1997, so last 25 years or so, in a box and whisker plot. The main thing to point out here is those red dots is the mean flow over time. So over time, it hasn't really changed. So there's different consents and those sorts of things of how they can peak their flow and things like that. But overall, it's been discharging in a similar manner ever since really about 1972 when it became fully operational. And something to point out there is that on average about 380 cumex. And so just a little competition with Gary's numbers, he's throwing out some big numbers there. The amount of fresh water that's come through that power station would fill about 240 million Olympic-sized swimming pools. So it puts in perspective how much fresh water does come through that station. So just to give you some background on how we measure things for the physical environment, and then I'll get into biology. We have a system in both Doubtful and Milford Sound. We're able to dial into that system through our internal ocean observing system, if you will, at the Cawthron Institute. We can see the diagnostics of those systems. We get the data in real time. So about every 15 minutes, we get temperature and salinity at various depths in both Doubtful and Milford. I'll walk you through how we typically graph these data so that people can understand how the system works. What you see in the top graph there is wind and rain coming into Deep Cove. You see the M4 mooring, which is in the middle of the fjord there. I happen to put some sensors, this is in 2007 actually, I put some salinity sensors in Deep Cove at that site to capture what it would look like there as well in terms of salinity, and that's your tail race discharge there. So as you would expect when you have a constant freshwater flow between these weather events, you have a very shallow LSL, 2 to 3 meters, up to 4 meters, even right there, up there in Deep Cove. It gets shallower as you go out in the main channel. You get a bunch of rainfall. You get a really strong sustained winds that are going up fjord. It gets channeled up, and that's what holds that water up and causes a deepening event. And that's how you get that significant deepening event there. Something that I always find just fascinating is that you can be in completely different fjords and the same thing's happening, almost in synchronicity. So you have Milford Sound over there, the same events happening. The obvious difference being that between rain events and deepening events, you don't have a constant shallow LSL. You get a bit of it after that one there, but nothing like in Doubtful Sound. If we look at water temperature, again, that similarity between Milford and Doubtful is quite stark, actually. I mean, you really can't tell too much between those two graphs there, showing this was in, let's see, 2021, going into 2022. This is that big heat wave, just that big red bar, both Milford, Doubtful. You do see cooler temperatures near the surface in Doubtful when you don't see them in Milford, and that's the effect of the tail race there in the shallows. Some not so exciting happy news here. These are the mean annual water temperatures for the last 18 years, actually 20 years I think I have in here, down to 2005, showing these most recent years are in fact quite a lot warmer than the previous years. So there is something indeed happening. I'm going to walk you through some biological results and show you what we do in that regard. So we have about a dozen or so sites between Doubtful and Milford Sound where we do biological monitoring. So when you come to the rock face wall where these sites are all located, they're permanently located sites. We work all the way from the intertidal down to about 16 meters depth, sometimes deeper, because what we're doing is we're basically photographing the wall. When I started the program in 2006, I went in there with some construction divers and we drilled 300 holes in the granite wall and put cattle tags on those things, and we can re-photograph them every year, the same exact place on that rock wall. So we have about 300 permanent photo quadrants set up. We do randoms, we do heights of different critters of where you might expect to see them on the wall. Everything that might be affected by the low salinity layer that sits on top. NIWA carries out these deeper water transects for black corals and other indicator species, and there's some fascinating data that come out of there. So I'm just going to show you some highlights of what these sorts of, the way that we've set it up, what it allows us to see. And I always believe, stats and all the math aside, a picture speaks 1,000 words. And it resonates well with all the stakeholders and stuff. So I like to use video and I like to use photographs. So I found that in some of these critters we've named, just so you guys know, I'll mention some of their names. There's Henry the horse mussel. I didn't go this year, so I couldn't go get his photo. But we have, for instance, here at site 11 in the main channel. This is quite a biologically diverse site. This is at 10 meters depth. We have a little baby black coral there. That was in 2006. And just a few weeks ago, that's the same coral over there in 2024. And that's kind of cool. The same years for that same site, but for 2 meters, 10 meters, and 16 meters. And this is what you want to be able to say is that, well, 18 years later, if you looked at those slides over there, they actually don't look much different than these over here from 18 years ago. And you can even see some of the same, so that's SpongeBob. And we see him every year, and he's still there. Even these sponges here are there. This saucer sponge is in that last photo as well. So that's good to see, especially when we hear about bleaching and things like that. It's good to see that those critters are there. So the way that we analyze these, so that would be that site 11. This is in Deep Cove. So we'll do all these analyses of those photos. Then we run statistics on the numbers that we generate for the different abundances of organisms. And then we can look at the similarities of those communities within a site for different years and then across different sites. So what we would expect to see then is if something bad was happening, you might have this site starting to look more like Deep Cove or something, or vice versa. And so what we've been able to see throughout these 18 years is no directional changes that would imply that something's going on. But we do see changes, quite a lot, that we've been able to capture. A lot of them are driven by things like urchins and sea stars and those sorts of things. And just to give you a couple examples, this is a site in Milford Sound where there's just heaps of Cosnasterius, 11-armed sea stars. This is a site in Thompson Sound where we happen to have a student from Otago taking pictures during other seasons. So she captured pictures during the year that we wouldn't have caught during the monitoring. So what it shows is that you got mussels. Here it's at 4 meters in Thompson Sound. She happened to capture this event with sea stars. She was there in the winter, they were gone, and then we did our monitoring the following year. So if we didn't have that student doing those studies, you might think, well, why did those mussels disappear? And so off the back of that, we did this really cool study. It's not as cool as the penguin camera. This is a sensor on a sea star, so not quite that expensive. It doesn't really move. I can't show you a movie of that. It wouldn't be really exciting. But what is super cool about this is that that's a little temperature depth sensor attached to this. It was sponsored by Star Oddie, so they loved it. They used my photo in their ads and stuff because it was a sea star with a Star Oddie sensor. But anyway, you can see in this publication, what we could calculate is how fast they're moving up and down the wall, which is quite cool, up to 2 to 3 meters a minute or something. And they're measuring temperature while they're doing it, which is pretty cool. One of the other cool studies we did, this is in Deep Cove. This will make you feel good. And they saw these just a few weeks ago. This is a video I took a long time ago. It's at Site 5, right there in the heart of Deep Cove. If you swim down past 20 meters, you see these massive black corals, and they're just after a shelf. And I'll explain probably why they're there in a second. But we did a study where we knew where the upper depth limits of corals are throughout these sites. So what happens is when you're in Deep Cove here, they're quite deep. And then as you go out of the fjord, they get shallower and shallower. And that's likely due to the depth that low salinity layer gets to, right? And you see it in Milford as well. So we built a numerical model, a statistical model based on those observations, fed in numerical data from a hydrographic model, kind of like the one that Jack was describing, and basically got a really good fit between what you'd expect to see using the model and the observed for these different corals at these sites. But what was really interesting is in Deep Cove here, M5, and even on the inner site at Milford Sound, you could see juveniles where you'd expect to see them, but not those big giant ones I just showed you that video of. And so what we suspect is happening there, because what the model tells us is rain and wind is really what's driving things, okay? But in those other areas, it's probably things like landslides and sedimentation and so forth. So this is my last slide, I'm going to it. I just want to pay tribute to Ken Grange, who was a Fiordland Marine Guardian. He's the one that basically discovered black corals. And I think this quote that we got from Ken really resonates with some of the things that were talked about today, including climate change and those sorts of things. It is a special place. Thank you very much.